Hi everyone, welcome to ST Skills. This is a weekly system design series. The format of this, as per current schedules, is like 1 week we have a mock interviews where all of them be a silent listeners first, and one of them, like two, there will be interviewer and interviewee, and they do a mock interview, and then we do a collective feedback. That's 1 week, and an alternative week is we do a deep dive on one of the specific topics. Any system design, it can be research paper or a specific topic, like example replication, HTTP, like that, anything that you want to present. And this is volunteer based. If you would like to learn and present a topic, please ping me in Discord. Um, so today we are going to cover an auto suggest or auto complete or a Typeahead. So this was actually a mock interview in the last week, and we decided to explore on the same subject this week in the as part of deep dives as well. So because there could be many approaches, and we have a lot to learn in this area. And this is one of the frequently asked system design questions as well. So with this, like today, Abhishek is going to lead this session. So, and I'll hand out the forum to Abhishek. Please take it.
Yeah, thanks, Naga. Hi, everyone. I'm Abhishek. Today, I'm going to talk about this auto suggest or auto complete or type ahead system design. So, one disclaimer I want to make is so I could not find any research paper about it. So, the things I'm presenting are like based on my understanding and the things which I have found some resources, but like those resources are also people's opinion. So yeah, so I mean, we have to take them with a grain of salt. Okay, so now moving on. So first, I want to start with like what are the scenarios we would need auto suggesting? What are some of the examples? So one use case I see for auto suggest is that it will help users query faster because they will get that suggestion and then don't need to type the entire query and they can just use that suggestion, right? Other thing is that sometimes users are also interested in what are the trending queries. So basically for a given term they want to see what are the people searching related to that. For example, if you just type Google, if for fun, if you just type what, you want to see what people are searching starting with what, right? So the common examples you would have seen is on Google, Bing, and Amazon search, right? But another important scenario I want to mention is like there is also this mobile keyboards and they could be offline and online, but let's take an example of offline mobile keyboard that will also auto suggest you based on your history that what is the next word you want to type, right? So I mean, this auto suggest, it's not always, it could not be always distributed. Another way to see it is that, you know, like offline, you are storing the history of user's data on his mobile on that storage and then providing him suggestions, right? So I think that is also important question to clarify when someone is asked that question. Okay, so now uh, moving on to requirements. So in my mind, like the requirements for this uh, feature would be that given a prefix, you have to return what are the top k most frequent queries for that prefix, right? This is the basic thing you have to do. And this autocomplete API call, it should be invoked on every key press. So every time a key is pressed, this API will be called. And then there will be another API to store that user query, like what the user has finally decided to search for. And that will be invoked once the user has pressed enter or once the user has finally decided that this is the query he wants to query for, right? So that's why I see that the reads will be a lot more because you have to invoke this call on every key press, and the write will be invoked once you have uh, completed your query. right? Uh, the other thing is whether the system should be real time or not, right? So what do we mean by real time or not is that if a user, if some of the queries are trending and it has recently started trending, those queries, should my system shows those queries immediately in the auto suggest in the real time, or it is okay that I have some offline processing system right now, a lot of people were searching for some query, I will do some offline processing later after few hours, probably after 3-4 hours depending on my offline processing duration, then it is updated and now I show that hey, this query is trending. So those could be the two ways to develop the system, like that, whether it's like more offline it is creating those suggestions or it is creating real time those suggestions, right? But very important requirement of this system is that it should be very low latency, like your read should be very 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 fast, otherwise like there is no use, because then the user would have already pressed another keystroke and you would have lost that time, right? This system should be highly available, of course, because like you want to show your auto suggest queries. But I believe like, so what happens is if your system is not highly available, then for that duration, you will not have the auto suggest features. So I think highly available is a very good to have functionality, and it is expected from most distributed system. But in this case, if your system becomes unavailable, like you you like it's not creating any like major issue for the user as far as I can think of. uh, Now talking about the consistency, right? So consistency is not important in this system, and why consistency is not important? By consistency we are saying that everyone is seeing the most up-to-date information, that what is the most frequent query, and two users should see the same set of most frequent queries. All these things are part of consistency, right? And none of the things are important here. If I see top K and my friend sees some different top K, it's okay, right? Because he doesn't know, probably it has changed, or probably my system was becoming eventually consistent. So for some time, some users are seeing different results, right? So that's why consistency is not important in the system. Okay.
So, Abhishek, one of the requirements I think which many people might ask is like personalization, right?
Mhm. Yeah,
Yeah, that's but definitely an additional, and it
yeah,
may be more complex, but like we can
great.
just add
Okay. Yeah. So another,
personal.
yeah, personalization, localization, right? All
Yeah,
those things.
yes,
Great.
yes.
Yeah. I mean, yeah.
Also,
Mhm.
one more thing, Abhishek, is how to eliminate the malicious or like hateful speeches, those type of stuff, right? I mean, I know it is not
Oh,
a
right, right.
base requirement, but I think that is one of the key thing what the search engine do. Otherwise, it would be really. I mean, that is the whole purpose, right?
Yeah, but I think it's a very good suggestion, right? That
Yeah,
any like probably some keywords which are
correct.
like malicious or which are not good for kids, they might be frequently used, but they should
Yeah,
not be part of the auto suggestion. Yeah, yeah.
yes,
I
yes.
agree. Yeah. Mhm. Okay.
Yeah, and one more thing, it's a client side or it's a server side? Where will the
What?
things be stored?
So yeah, so that depends on the first question, that are we making that offline system where we are uh, just auto suggesting what you have, what we have information you have, and it's only offline, it's not improved by the online system, then you can store on the client side. But if you want the knowledge to be combined by other users information, then we will have online system. But I mean, we could have offline system also where those machine learning models are downloaded on your device based on users. But I think, yeah, so it depends, it could be either offline or online.
Yeah,
But
as an example that you said that on the phone when you type and the internet is not connected. So are you going to cater to that requirement and then design this? So I'm asking you how you are going to proceed with this.
yeah,
It's online
so
mode, offline mode, or what?
so yeah, so my approach here I'm taking is that it's an online system, that the data is stored online. But yeah, we can definitely, that is also an important thing, that we can also build a system which works offline as well, right? Which stores some of those suggestions offline on your system, and it can suggest based on that.
Yeah, the reason I said is like when you make it online, so every key press is going to make an API call.
Mhm.
An API call itself, making an API call and then getting the response, it itself has a significant latency than reading directly from your own box.
Yeah, yeah. So yeah, but these web search engines like Google, Amazon, and all, they don't store anything offline, right? But still, they provide you auto suggestions, and
Yeah,
they do it online.
right, yes.
Okay, so yeah, so yeah, so now moving on to API. So I see like these two main APIs. So first is for read, that for every keystroke which is invoked, which will be the prefix keystroke, which is the prefix which have been created up till now, and it will give you the list of suggestions, right? And this another one is the write query, which is now we will store the query once the user has invoked the query. Okay, so now we have these APIs. Now, okay, let's go to the scale of our service and estimations. So this scale, got some references from one of the websites, and it is, I think, Google's references, but we can take it as an example. So the for the auto suggest feature, right, where we are doing the read, so basically assume we have 5 billion queries per day, and let's say the size of each query is 24 characters. So in a day, I would have to, my API will be called 25 into 5 billion times, 75 billion times, right? Because for every keystroke, my API will be called. So this will be the scale of queries.
So 125, I think. Oh, is it like the total or
Oh yeah, sorry. No, you're
queries?
right. Yeah, 125. Yeah.
Yeah.
Wait. So it's 25 characters. So I think your computation, is it like the size, or are you saying total auto suggest queries per month, or
Uh,
what is your calculation there?
my calculation is how many API calls would be made to my system in a day.
Oh, okay. So for each character, if you make a call, so yeah, I think it'll be that's fine.
So, Abhishek, one more thing. Is it really we need to call the system for every character? Because the system that I worked on, I mean, the front end was not sending for every keystroke. They were waiting for some amount of time before calling the auto suggest. But it
Yeah.
may be different. Like Google can handle even for one cat.
Yeah, even I was also thinking about that it's a good point that.
Actually, they will actually wait for a key pause, I think. So, I mean, like there is a small pause which we can't recognize. If you are
Mhm.
continuously typing versus like if you give you kind of wait for result. I think there is little difference, but I don't know if they always follow that. But at least for the first few characters to type in, so it will filter a lot of things. So I think for
And
first. Mhm.
and I don't think it'll be API query on each. I mean, the response would come from CDN in most cases because popular queries would be cached already on CDN as the API responses, and also I think the
Mhm.
actual call would be much less than what will go to the application servers.
What
Yeah.
is CDN? Sorry.
Yeah, I
Content
was saying
delivery network.
yeah, CDN.
So, but making a call to CDN is also like overall it's an API call, right? And now that API
Yeah,
call has been optimized
I mean,
by
yeah, I mean,
making
from
a CDN.
client perspective, it would be faster, right? Because rather than having servers all around the world, you are leveraging the network which is already there. So and most of the time it will come from memory, so it'll be faster than going to the application server in most of the cases.
And one more thing, what I'm thinking, right, for Google or Facebook, they do not rely on other CDNs, so they have their own CDNs, right?
Exactly.
Right.
Exactly.
So,
yeah.
so one, yeah. I mean, if we
Own
think
data
about
centers.
in their scale, right? I mean, CDN is it is low latency, like we can identify almost every part of the world, they have. But yes, there will be a call, but it won't, and they have to updating their CDN cache, right? Yeah, that is true. Definitely,
So
it won't be
Correct.
happening.
yeah, and I mean, so
But
I
there is a
have,
network call.
yeah, there is a network call, and another point is, uh, do we know if they use CDN? Because see, if you have uh, a static like URL key and you have a image or something big data and that you want to pull, you use CDN, right? But here in this case, you have to do some processing. Some processing is because there are for that prefix. I mean, you don't know, like that prefix might have lots of result. There is not fixed result. In the case of image, for that particular URL, you know that this is the image, right? But here
Yeah,
for
and
that
yeah,
prefix.
and yeah, that is where I think it is more useful, right? Because it will save those processing over and over again. So I mean, I agree, like it'll be different for each type of query and all, but think about popular words. Say somebody types AWS or Azure, things like that, right? It will be much more useful for those kind of popular words that somebody would type.
But
And yeah.
mhm. So I'm saying isn't but CDN for static kind of content, the image or something?
Not always. No, it can cache dynamic content as well.
So
Yeah,
should we be saying CDN or should we be saying the edge? I mean, this is
Yeah,
the
they
edge
are the same
computing.
This
actually
is, yeah,
normally,
they are,
right?
yeah,
Uh,
correct. CDN
So
has
edge
edge servers.
computing is nothing but yeah,
Correct.
like basically, like your request has to, for example, whenever you are accessing, right? Like it goes to the ISPs, right? ISPs are distributed, and then from that ISP it has to route to where is the nearest CDN, right? Because your server might be somewhere different in the world, and then CDN, if CDN doesn't have, then it has to go to destination, right? Yeah, that is
okay.
the edge computing basically.
Okay, so one interesting question here is, so on every write, right, my results might change. So then my writes are so like could be so expensive that all over the world, whatever CDN networks I have, I will have to update them that, hey, for now this query, these are the top case suggestions.
No, it depends
I
upon the
think that,
configuration. You don't
So
might have to update
yeah,
in the entire world. You can configure it to update in just that region or even within the region. So that depends how you want to do that.
yeah, just my thought, like sharing here. So when we say CDN, like my thought process is like CDNs are likely used for images or frequently used videos and all. In this
Yeah.
cases, probably it may not be the right term, I guess, because when we say edge locations, we actually have web servers also there. I mean, like the Facebook or whatever the top companies, they have the edge locations very closer to the user across the world. So I think it goes to the server, and they will have a cache specific servers which is equal or similar to CDNs, but not exactly CDNs. That's what
Yeah,
I
yeah,
think.
right. That's
exactly.
right. I mean, even though she's saying CD and it is nothing but a
Mm,
point of presence, that's pretty
yeah, yeah,
much it.
point of presence. Yeah, yeah, that's
Yeah,
correct.
Correct. Yeah.
Point.
we
Mhm.
agree. Yeah, yeah, that makes more sense.
Yeah,
Yeah.
but like when we use this term, like it could mislead people. Like,
Yeah, because yeah, even I
we
also
can,
I have been
yeah.
thinking about CDNs as that you have those static images, videos, which is a large
Mm.
content which is not frequently
Because
changing.
like all news sites, like wherever they have this frequently used pages, so you can just cache there. But like this is kind of an API, right? Like it always has to go through some web server,
Mm-hmm.
so not directly. Like it's when you have a static URL, that's where like you use a CDNs or like, or for even video.
Yeah, yeah. Okay,
Okay.
nice discussion. Okay, so
Hey, I have one more suggestion. So what the whenever you log into some website, right, like Google or something, they could also store a cache. They could also store a cache and bring it to your local system as well, right? Like if you go to Amazon, right? If you log into Amazon.com, then once your personalized results get loaded onto the website, they could also store this data structure, which would store all the autos, the type ahead suggestions into your cache so that it will be pretty fast. For example, even on Google, right? After you type few words into google.com, like some full name or something like that, the next few words, it wouldn't try to autocomplete everything from the beginning, but it would autocomplete only the last few words.
But I think cache is used whenever it's a repeated operation, right? But are we sure like the customer is typing similar queries all the time? He may search anything, right?
Yeah. Cache is nothing but an in-memory store, like a key value store or whatever this data structure stores, right? It doesn't always have to be something that the user does it frequently.
Yeah, I think that's a good point. So
Maybe, yeah, I think what I feel is like for the when you are saying that, like I realized, so there are some queries which you may repeat the same things again and again. For those kind of use cases, it may be okay to store some set of queries which you are doing frequently in your local machine. So is that
Yeah,
like it's
and
the
even
form?
not the ones that you do it regularly, because for every keystroke we don't want to hit or do multiple hops to get the data from a server.
Yes, yes. Yeah, it's
and
basically avoiding as much as hits to the server. Like, so
Yeah.
that's where like we think about many other solutions.
yeah,
Uh,
yeah. And
Uh,
what you're saying is, I think they show it in a different color also, that you have searched for this term before, and probably that could be pulled from your local cache
Yeah.
because you have searched for that term. So yeah, for you it makes sense. Although it might not be top K frequent now, but because you have searched it, so for you it's relevant. So
No, I think
Excuse me. I have one more question. No, not a question, but a suggestion.
Mhm.
Does the requirement of having like how many suggestions we need to show, is that a part of a requirement, or it can be like if I'm designing, I don't want to fill up my entire page with the suggestions, right?
yeah, I think he
Oh,
said top
okay.
K, but he didn't
Oh,
like
top K.
say,
Okay,
yeah.
got it. Okay,
So,
Oh
understood.
yeah, top K. Yeah, top.
Sorry, I missed that. Okay.
Mhm.
Yeah, I have a question here, Abhishek. Help me understand. Maybe I'm confused here. Is like when I type on, as an example, when I'm typing on Gmail or so, I see if I type "let me," it will give you "get back." I mean, that kind of suggestion, right? Is it that piece that you are working, or it is like with every hit it would try to complete the word with those? What do you mean by K here?
Uh,
Can you give an example?
So, are you talking about the Gmail example where it suggests you to complete the sentence?
Or let's even say Google. Help me understand. Can you give me one example? What do you mean by K? That you will request give me K words, or it's trying to complete the sentence, or it's trying to complete a word.
Yeah, it could be
no, for
anything.
any suggestions, I think if you type it lists up to 10 or something, right?
So it
Yeah,
could
so
be
if you
something
see,
like say,
Like this, right?
let me find,
Okay, this way.
let me show kind of thing.
So then
So
there
if
is
you
what
look at the
Mr.
screen right now, there are 10 suggestions. So that's the
Oh,
top
okay,
10.
And so
okay.
see, like so someone was talking about these I have searched before, right? So these are from my history, and these are actually from the web. So I think these are pulled from cache probably,
no, I
and
think
there
it
is an
could be
option
from
to
your
remove as
server
well.
remove
also.
it as well, right? So
Yeah,
that's why it was
that could
from.
be your local one. Yes.
Yeah.
Okay, I got it. Thanks for
But if
clarifying.
it is personalized, it can be on the server also.
Yeah, yeah. It could be, yeah, that I agree. It could be on the server.
because your search term has to be continuously harvested, right? And yeah, I mean, that is one of the advantage of taking, like, if you search the words, it may not be a browser. I mean, normally that's how Google actually takes all your data points, and apart from your recent searches which are on the browser level.
And Abhishek, for the timing, I know we mentioned like very low latency, but I think they need a really low latency. I mean, I think, I don't remember correctly, but it should be less than 50 or so milliseconds.
Okay. So you are saying, okay, we should put some numbers here that it should be less than.
Yeah, when I was working on that, I couldn't find anything, but someone was saying like 5 milliseconds, but I think it's too much, right?
Yeah.
I don't know some exact number, but like what is the minimum latency we need to make it helpful?
Yeah, I don't know the numbers. Yeah.
So here the vector distance will compare whatever you have written and whatever suggestions will be there. So whosoever vector distance is minimum, that will project. Is it like that based on the probability or something nearest neighboring algorithm?
So yeah, there could be there could be multiple algorithms. So what you're talking about, nearest neighbors and all, would be like more advanced in this sense that they could also search for the terms which are not exact prefix match, right? So let's say, for example, I'm searching for Mike, M-I-K-E, right? And it could suggest me things with Michael, M-I-C-H. So there you're using the nearest K neighbors. But in our design, we are discussing simple prefix match that given a prefix, you have to find strings which are with the same prefix. We'll see like a lot of challenges in that design itself. And so so I did not get time to think about other approaches, but yeah, we could use those other approaches as well.
I
Hey,
thought when you,
Abhishek,
okay.
I see you have a try here in the next slide.
Yeah.
What about discussing how you are going to solve the problem before you can scale it?
Yeah, right. Oh, yeah. Okay, sure. Yeah. So you're saying let's solve this problem on a single machine and then discuss about scaling it. Is that what you're saying? Okay. So.
So I'm a little confused about. So I don't know a lot about storage. How did you come out with 12.5 gigs?
Yeah.
Because I'm just calculating that, and it's looking like every query you're expecting it to be what, 1,000 bytes.
So yeah, this information I got from some website that on Google they have 500 million new queries per day. So they have 5 billion queries per day we talked about, right? But out of the 5 billion, some percentage of queries are only new queries, right? So that number estimation was 5 million, right? So So these are the new queries that we have to store. For others, we have to just increase the count, right? And so now.
Sorry, what I mean is, so you decided that every query is about 1 byte? Like I'm
every
a little.
query is about 25 characters and 25 characters.
Into 500 bytes, right? Like,
so 25.
what is 500? Oh, it's 500 million. Okay. So you are taking like 1 byte for character. Okay.
Yeah, and
It's 1 byte per character. Okay, that makes more sense. But I didn't know that 1 character is roughly 1 byte.
Yeah, I think some Unicode versions require 2, I think, but like the most.
Unicodes need 16 bits, right? Yeah, 2 bytes.
Yeah, 2 bytes. Yeah. So otherwise, like the ASCII, I think 1 is.
Correct. Yeah, ASCII is 256.
Yeah.
Okay, thanks.
Okay, so yeah. Okay, so now let's move on to this basic algorithm, like how we will like how we will solve this problem, the basic data structure, right? So basically we want to find all the prefixes, all the sentences that match that prefix, right? So for example, let's say a user has typed a, right? So what you want to do is so basically for I'm sorry, so first what you're doing is you're creating a trie, that for each word you are storing it in a trie. So ape was stored in a trie, api was stored in a trie, right? So you have created a trie. Now when you want to use auto suggest, so if a user has typed a, you have to go through all entire subtree and find what all sentences start with a, right? And then from there you have to pick top k most frequent. So let's say my k was 2. So for a, I will go here, I will see that ape has 5 frequency, api has 10 frequency, all has 11 frequency, right? So I will pick top 2, 10 and 11. Similarly, if the user has typed AP, so now I will go to the subtree of this and I will see this has two things, 5 and 10. So I will pick them here, right? So basically on this read, we have to go through this entire subtree and rank and find out what are the top K most frequent, right? So one optimization that we can do here is uh, that for each term, once we have calculated that what are the top K most frequent, we can store it with that term here, right? So for A, we can store that API and all are most frequent. And now this value will be updated on write. Whenever this try gets updated on write, this will be updated, but now my reads will be pretty fast. I don't have to go through this entire subtree. I can pre-calculate this information and store it over here, right? So this is the basic data structure that I think could help give your reads very low latency by pre-filling this information for each prefix. So now a question comes here is that, okay, so now for this prefix A, I know the results are API and all, right? So now how do I store them? Can I store them in a hash map, or will I store here in this try? What should I use? And I think in the last discussion also, there was this confusion that do we use hash map, do we use try, right? So I just want to discuss about the two data structures little bit, this hash and try, and what situation will you choose hash as a data structure, what situation will you use try tree or binary search tree as the data structures, right? And this will help solve a lot of our problems. So basically hash maps, they are really good for exact lookup. If I know that exact key, I can get that value of that key in big of one time, right? But the problem with hash maps is if you're looking for range, if you're looking for some nearby values with that key, right? You don't know that. So in this prefix case, you don't know what your exact key is. You just know that my key starts from A, but you don't know what those sentences are, right? So here you won't be able to do it with a hash map, because either you would have to iterate, if all of these sentences were in a hash map, then you would have to iterate through your entire hash map and see what keys start with this prefix A, which will be very inefficient, right? So basically whenever you're doing some range kind of queries, then you use these binary search tree or tries. So let's say you have some numbers, right? And if you are looking for some nearby numbers, that for 5, what are the nearby numbers that I have in my data? So you create a binary search tree, a sorted tree, which has that related information near it. Now if you do this in a hash map, it's not possible, because hash map can find you the key 5, but it will not be able to find you the nearby things, right? So using that distinction, so the strategy I think is that now once for this prefix A, you know that these are the top K terms. I think this thing you can store in a hash map, because now you know that fixed prefix A and these are the top K terms. So that part you can store in a hash map. But when writing and when you have to do the calculation that what are the top k uh, words or sentences for that prefix, that information you would have to store in a try.
Abhishek, one question. What will be the value in the hash map?
So yeah, so I'm saying like once you have created this kind of structure, then in hash map you will be storing, let's see if I can, okay. So in hash map you will be storing that for key A, values are API and all. For key AP, values are ape and API and so on. So now, so I'm saying for your read path, when you're reading, you don't need to go to this try or anything at all. You just find that word, you create a hash of it, and then you can directly get your results because that information is pre-calculated.
Don't you also need to store the frequent in the value too?
Yeah,
Then
I mean, you can.
otherwise, how do you know when you need to update?
Yeah, so update. So I'm yeah, update part. Yeah, okay. Yeah, that yeah, we'll move over there, but that's a good point that you will also need to store the frequency of API is 10, frequency of all is 11, so that on your right path, when you have to make updates, you need to know which one to replace, which one to not replace. But yeah, we'll do that. But yeah, let's focus on the read path. So can we say for reading, I will create a hash map out of this try because I know exact key for what I want to find the sentences. And so I can store that in a hash map and quickly get those values.
So one question, right? Like here, I believe there is a comment on the personalization, right? So does the try structure consider the user preference? Because if two users are trying A, one has to get API, the other has to get different, right?
So I think let's separate.
Yeah, let's keep that aside.
No, I mean that's a visual thinking, like right? That's a visual thinking. Let's try to solve the basic problem at hand, and then we can add a layer of personalization.
Okay. Okay. Yeah. Yeah, because I was thinking like this try has to be a global structure, right? Or it has to be a user-based structure, something like that. Okay.
Right. And with respect to hash map, in my head, I was thinking like, why don't we just keep a reference of where the API is, like, you know, the node where the last I is. Because whenever we are creating trial, let's say we go to API and at the ith node, we have this word API, correct? So why don't we keep the word itself and along with the frequency of it at that and keep that reference in A or AP or something like that.
So I didn't get your point.
Are you suggesting to include that information in the hash, or are you suggesting to include it somehow in the nodes of the try, the way it is now?
I think along the path, he's suggesting to have all the children metadata as well. I mean, like at least, is that correct? Like at least the top K ones?
Right, at least the top K ones, we can just keep a reference of top K starting from this letter, character A, and not store the entire data. I don't want to store API. I don't want to store all. I just want to point the reference of that node. And when, let's say, I hit a backspace, that API, the ith node, along that, if you go down the path, API, at the ith level, like at where the character I is there, right? That reference you store it in A, and that reference you store it in P.
Okay.
Yeah, but wouldn't that be the same? Because when you store API, you also store reference only. You don't store the whole string. You store the reference.
Oh, we are storing the reference here. Okay.
I was talking about storing the entire string, because if you're storing the reference of I, so now at the read path, when you have to get the keys for A, right? So you will go through this and you will find like you will go through this reference and find what is the word. So you will go through the parents and make that sentence and then return it to the user. Will it not take more time?
Yeah, I think the storing the word makes more sense than like storing the reference, because what is the use of storing ith reference, because you have to traverse the whole try path to get the full word, right?
So instead of
I'll say here.
actually so we can store the reference to the last node.
Right.
What is the use of storing that reference?
So in that case, we will not keep the data. We just need the reference to the last node. So like in that case for A, so API, so store the reference for the ith node, and for all, store the
No, but
reference to
what
the
is the use
all.
of reference? What is the use of storing ith reference? Like if you can store the API itself, why you want to store the ith reference?
Yeah, I mean, how much data it is, like, and so see, like the very first requirement of design is very low latency. So we have to do everything we can do to improve the latency.
Yeah,
And
so when you have the reference to the node, you can directly go jump to the node and read the value. So here you are duplicating the data.
no, but you have to create the string and you have to jump. So
you don't need to. So
Okay,
you
okay,
don't need to.
I get what Praveen is trying to say. I think what he meant is like in the ith word, we already store a word called API. Is that correct?
Right. That's
Yeah.
what I
So
was saying.
I think that makes sense. But only thing is, so when we are storing some results at eighth node, the idea is not to store all the children words. So the idea is to store only the top 10 at eighth level. So which means that A can have up 26 childs, and each of those can have like 26, 26, and it can keep continuing. I mean, like it not just 26, but like many other branches. So the idea of
So when we will, when we will build the try, so at that time we know that the word reference. So here, if we keep the reference, we keep the actual word at the last node, and inside the hash, we just keep the reference. So here you see that with A, we are keeping API, and with AP, we are also keeping the API. But if we go with the reference, we just need to keep the reference only, and actual data will be at one place.
It's still a hash map. It is just that you're not having replicated data. That's pretty much it.
I think we can have different ways of implementing
maybe
it, right?
Abhishek, like, can you list different approaches being discussed here? Like, what's your idea first, and then like what's other
let's go
audience
with
idea?
Abhishek's idea first. Yeah, that's true.
No, but it's interesting, and let's discuss this. So I have some questions regarding this approach. Okay, so now my approach was that these hashes, these are partitioned, right? And now you can balance the load. Now, if you're saying that I'm storing the references, how are we going to distribute the load? Because now whenever someone is calling AP or A, they have to go to this part to find the reference and the node. That is one question I want, that how will we solve that problem? Second question is,
It is just the top K that you'll be storing, right? It is not the entire list below A you are storing. I'm just talking about top K. That K can be 100,000, 2,000, whatever.
Yeah.
So I'll comment something.
You're not going to partition the top K as well, right?
It can happen, right? If your load increases. So basically you might have to partition at this point, that for AP, the data is different. Okay. But then there will be, okay. Mm-hmm.
Yeah, let me suggest one thing here. I mean, it's my thinking. Well, the thing that Abhishek is trying to draw here is for only read purpose. We probably need a separate place where you can store the whole string, and you can also store how many people have made a count on it, so that every time you are done with your whole sentence itself, you can increment one, and some other job which is reading all those a simple list of all the sentences, and can reshuffle or maybe fix this kind of try so that the read is fast. And I'm of also same opinion as Abhishek, that when you want to check, like when somebody press the first keyword A, then all the information of top n item should be stored within A itself instead of traversing downward. It could be the pointer, which you can call it a hash value, and maybe AP has the same hash value as P also. AP has the same hash value, and the sentence is stored somewhere else.
Yeah, but in this case, you are replicating the data, right? So let's say you will have some top K frequency. P, you will have some top K frequency. E, you will have some
Correct.
top K frequency. I, you will have top K frequency.
Yes.
But
You
it is
will
the
only
same
store,
data.
yeah, you will not store the whole data. What I'm saying is the mix approach here. Instead of storing the whole sentence API or so, just have a list of top N as a list only with every node, top N contributing or the top searched items, only those references and sentences are stored somewhere else. Just a hash value. So that you can look in the hash storage and get the full sentence. So API and AP, what was the other one? ALL.
Yeah.
So those sentences to be stored somewhere else in the hash or so, or in a list also. Maybe you can just store the pointer where in the list you can get this particular value for retrieval. So it will only have pointers so that it is also easy later on. If some other sentence move up in the bucket, you just need to change the pointer there.
I think
A pointer is assuming that the try and the hash table can fit a single node. What would happen if the try don't fit a single node?
Yeah,
in practice, we might need dozens, maybe hundreds of nodes. Then for every query, you need to follow these pointers and do several network round trips to retrieve the completions. So
yeah, I'm not saying the pointers. What I'm saying here is, let's say the A. In the try node, A has some other value also within the node itself, a list of pointers. And those pointers point to the address within the same box. Get all the sentences and return it.
So Hitesh, here you are assuming that you will keep your try and your hash on the same box.
Yeah.
So, but we don't know what Abhishek was thinking.
Yeah. Yeah. So I mean, yeah, I also had this thing in my mind, and so both approaches have their advantages and disadvantages. The advantage of having it in the same box will be that the writes are faster, because after write you might have to update this hash map, right? So now you don't need to do a network call over another machine where now you're updating this hash map, right?
Yeah,
but
correct.
The disadvantage is then you will need more and more sharding, because now each node can store less data, because your node is storing the hash map also in memory and your node is storing the try also in memory. But the another question on this referencing thing. Okay, so another problem I see with the pointer referencing thing is keeping the read data structure separate from the write data structure helps easily solve the problem of concurrent reads and writes, because while you're modifying this data structure during the write, right, your reads are not affected because you will not see any incorrect pointers or something. Whereas if you are mixing these two data structure, now when you are modifying this when you are writing it, you might see those incorrect references, and those are the other problems that you would have to solve. Those could be solvable, but those are the other things which you would have to solve. Whereas this makes it very easy that your reads are in that completely separate data structure.
Correct. Your point is definitely valid. Now the concern comes is when an API call over the network is made, if you bring another machine into the picture here, it's going to be more latent. Right? Yeah. It's going to increase the latency. Now your first focus is that your reads are supposed to be very fast. Yeah. So if you introduce, like I said, if you introduce another node, it's going to be a different problem. How can you contain your data within the single node? that will make it more latent, right? I mean, it will be better for latency from latency perspective.
So Hitesh, for reads, it does not matter, because I'm saying for reads, you will always go to the hash map. You never have to go here. So reads are always on this hash map. It's the write. During the write also, if you have to, during the write, you have to update this hash map. So I'm saying if this hash map is on a different box, then your write will have a little more latency, because you will have to update this hash map on a different box. If it's on a same machine, you can update it on the same machine.
But even, even like you separate the read from the write, and then, the hash map had to be updated too. So,
Yeah, but
how would that solve the
right,
problem?
it's not
Because
a
when the,
strongly
the frequency change, you have to lock the hash table and update the hash table.
So yeah, that was the first requirement, that it is not a strongly consistent system. So while you are updating your writes, and probably the frequency has changed now, it could have happened that ape is now more frequent word. Its frequency is 50, but I will eventually update it and fix it. So I'm not saying that I'm like very strongly consistent system.
So question, Abhishek, you are saying try is for write and hash map is for read?
Yeah, hash map is for read. Try and hash map will be used for write.
Oh, okay. So you are keeping the changes that are happening in, reading pattern, increase in frequency or so, that you are keeping in try. But when for completion, you are directly reading it from hash map and giving it to the user.
Yeah, right, exactly. So if you're...
That's a good one. The only concern I think here is like, since A and AP both have the same data, right? So, and the sentence can be significantly larger. So probably, instead of having AP and, all those data stored in this way, maybe you can have with A and AP, you can store the list of top N items.
So
Simple list.
Abhishek, just to clarify, your second point is actually storing the top keys on the hash map. Maybe you can just clarify that.
What point? What
Is
second?
it correct? No, I mean like in your slide, the second point, like you store the top key for each prefix along with frequency. Is it like on the hash map, right? That's what you meant to say.
Yeah, on the hash map. Yeah, on the hash. Yeah.
And Abhishek, your read and write would be two separate calls.
Yeah.
And they will also look different.
They will also look different. Yes.
So
they are...
for example, I searched AP. So you won't use AP to update anything.
You are searching, or you have like is it your query, or you are...
So my query was AP, and then I clicked on Apple. Now the write would be for the Apple, right?
Yeah, write will be for Apple. So when you typed AP, then the read request will be called, and I will get these suggestions from the hash map. But after, when you typed Apple and you pressed enter, that this is your search term, then I will update this try and store that information here. And then also appropriately, if this hash map needs to be updated, I will update this hash map.
And can you please clarify? I think I've lost somewhere. So at every node also you're keeping the words, like A would have all the children beneath A in the try.
Yeah, so I'm saying we need to store this information, that for A prefix, what are the top K most frequent. So I'm saying we can store this information in a hash map. So
Agree. Agree with that. But are you still keeping them in the nodes or no? In the try node.
No, we are not keeping it.
Okay.
Because we can always, whenever you need this information, you can always go to the hash map and get the information.
Yeah, agree. So I just want to clarify. So this is only try responsibility is to only have words with their frequency.
With their frequency, yeah.
But
and 1 second, sorry. And on the hash map, you would be having the prefixes and their suggestions.
Yeah.
And now this prefixes, I think in the estimates you considered, but this prefixes now go really in any direction, because I could, if user starting really big prefixes, Apple or something, then your hash map would have a lot of different combinations.
Yeah.
Or are you considering like some optimization only? I will take 3 or 4 character length prefixes, and rest I would go and look somewhere else. Or you're putting everything there, like whatever user has searched till date, it will become a new prefix.
Yeah. So I was thinking of distributing this hash map and storing all the possible combination of prefixes, but I think, yeah, it makes sense that like this, we could have so many possible combinations which might not be useful, right? And so we will be wasting a lot of space.
Because I searched Apple, nobody searched Apple in the
Oh,
world.
yeah.
It will go and put an entry there, and every time now when you are updating this, the try, you will be also updating all the prefixes, right?
Uh-huh. Okay, yeah. So yeah, I remember. Okay, so what I was thinking here is that this hash map will be only created for the sentences which have some weightage. So let's say if you search for Apple, right, and Apple did not have any weightage, so then I will not update the try because its weightage was very low. So this hash map will be only for those prefixes which have high enough weightage that I can say that the users will be using these prefixes.
But if you will not even add it, it will never get a weightage, right?
No, it will be added in the try, but it will not be added in the hash map.
So you have another component of weight, which is driving from frequency, or
Yeah, I mean this frequency or weight. Yeah, frequency is here like kind of refers to that weightage.
So
Hey,
that means
Abhishek.
if I put Apple and very less frequency or weight, it won't be in the hash map. Then we'll go and search in the try. Is that
Yeah,
correct?
it will be for the right path. Uh, so for the right path, it will be there in the try because its frequency can increase later, but it won't be updated in the hash map because it
Correct.
has.
But my query was Apple.
Uh-huh.
I put
Yeah.
a really big query. So generally, if you see on Google also, sometimes we copy paste from somewhere and put a really big query. I think they don't show suggestions in all the cases, but let's say I'm putting a really big query. So
Yeah.
my question was that, and then your prefix table does not have that this hash mapping. Then it's a try would be a fallback or not?
So if you have entered a new query, which is very big, it will be stored in the this prefix try with its weightage, and the weightage will be less, but it will not be stored in the hash map.
No, why my queries?
Because these are the queries, right? API, and these could be multiple words, but these are the queries. So for multiple words, you need that space. Like space will be your next term, but.
So
I believe Asim is trying to ask here, like, if something does not exist in a hash map, will you provide a functionality to look it up into a try and then return those results?
So if it is not in hash map, then I will not show the autosuggest, right? Because that is not such a frequent query. So I don't have any top case suggestions.
Then what point you decide this is the free? So I put a Apple as a query. It is not there. Then another person also put Apple. So at what point we are deciding? Oh, you meant like when you have some threshold on the frequency, that time you put that in the hash map.
Yeah. I got your question. I think let's. I think we can go to right path, and these things will be more clear. But okay, let me quickly do something here. So now you're saying the query was Apple, right? So when the Apple query comes, I will store it in my try, right? And I will say the frequency is 1, right? And during the write path, I will see whether these prefixes, they need to be updated in the hash map. Do they have high enough frequency or not? So I will see that the frequency is only 1, which is not high enough for me. So I will not update my hash map. But if multiple people are using and now its frequency becomes 15 or something, now I will make it start, I will make this as part of my hash map. And now then I will start adding these terms, APPLE, in the hash map.
Okay, now what your hash map will look like
So,
at this point?
So now you're saying the frequency has increased, right? It has become
Let's
15.
say 15 people searched Apple, like they
Yeah.
put Apple. Now what will happen in the hash map?
So now
So
for
you'll drop the lowest one that's already listed. So for example, if
No,
for
right now
AP
there is nothing in hash map. Hash map is empty.
I
No,
see. But
hash
okay,
map.
but if it were not empty, you would
No,
drop
no,
the
let's start with day
lowest one.
one. My hash map is empty. Let's start from there and then come to other cases. Now my hash map is empty. What
Okay,
will
your
happen?
hash map is empty. So someone was 15 people have searched for Apple, right?
Apple, yes. Now what will happen?
Yeah, so now I will see, oh, this has reached a threshold that it could be considered for auto suggest. So now for prefix A, I will store, for A, I will store Apple.
Okay.
For AP, I will store Apple.
So you will consider everything like A, P, P, L, like all the things.
Yeah. I will store Apple.
Okay. And now, okay, sounds good. And now let's say I'm now storing something like apples.
Do you store the final value or not? So for example, would you also store Apple somewhere with no autocomplete?
Oh yeah, everything will be stored in the database as well.
Because right now I see 4 entries in your hash. I'm asking if you'd store the 5th, which is the full word.
Oh, the full word Apple. Are you saying for Apple also are we storing this? I don't see a point of.
I'm asking, are you doing that or not? Like basically, you need some knowledge that it's a full word. So like, are you just not storing it in the hash, and so it doesn't find the key and doesn't make any extra suggestion, or what are you doing?
Yeah, I mean, I cannot store it in the hash map, right? And then, so it will not be the part of my hash map, so there won't be any suggestion. Because anyways, user has typed
okay.
Apple, so what's the point of showing Apple as a suggestion?
Yeah, okay, good.
So now somebody put apples. Like 15 people search apples. And when they put A, you showed apple, they didn't care about it. And so that would be a scenario, right? Somebody will put A, that will show apples. They will put P also apple, and user also put apple. Then also it didn't show anything. But then user also put S at the end, then hit enter.
So now my try will be updated with apples, and this word has frequency 1. So I will not update anything in the hash map up till now.
Let's
But
say
when you update
15.
it in the hash map, are you putting in the word apple or apples? Because now,
No, he's not putting. He's telling he will wait for his magic number or a threshold number. Then only he will take action. So 15 people searched apples. You showed the suggestion apple to them. Although when they are typing A, P, P, whatever, and they never cared about that. And at then they put S, and then 15 people did apple. So now your count become 15 there, right?
So for
wait, but why is 15 the threshold?
Okay, whatever there could whatever magic number. If you think it is 100, let's make it 100. But let's say there is n there.
Yeah.
So 15 or whatever n people did that, and then you get apples now. So now you will go back and update your hash map that time, right?
Yeah. So you are saying now n plus 1 people have searched for apples, right? This has more frequency, right? Yeah, so then we will update this hash, these hash map with
Now you'll put apples in all of them.
Yeah.
Can you just do it for me? No, you will also have
Not sure
apple,
how I
right?
feel about that.
You will still have apple, right?
Yeah, I mean, if it is top 2, yeah, if apple is the second most frequent, then I will store apple and apples, yeah.
You can you do that favor for me and do it like that? Okay, thank you. Okay, so this is how your flow will look like. Got it.
Okay, but now are we okay, so now are we saying that, yeah, I think I get your point. So these suggestions are not good, right? Apples and apple for A.
No, they are good. Like our algorithm is not to find like whether it is good. We are just trying to find out what is a pattern. And now if anybody put A, you will show him apple and apples.
Apples and apple, yeah. Apples on the top because it has most frequency.
It has yeah, and based on your K, you will keep on also cleaning this thing. If more words are coming in, you will remove the oldest word.
Oldest word, yeah. So we'll go to the right path. I was talking about the read path. Yeah, so that's what happens in the read
So
path.
this is also the right path only, Abhishek, because now let's say you are only showing 2 top suggestions.
I'm confused about why your threshold after Apple should be n. So like, let's say 5 people had searched for apples and 15 had searched for apple singular. Right now there's nothing else in the try. So if you wanted to show the top 2 results, you still would, right?
Yeah, I mean, yeah, these are the improvements and enhancement. You are saying that, yeah, that even if we don't have anything in the try, number 1 is also good enough to show as a suggestion, right? So yeah, I mean, we can do those things, but the thing is then like our hash map size increases. And why would you want to show someone a term which is only searched by only one person, right?
Sure. I mean, I guess, but I think that's like, then how are you setting your threshold? Like, it kind of seems,
So I'm saying
Threshold is just an arbitrary number that we have to come up with. Like,
yeah,
it can be 10, it can be 50. It is not we have to decide what should be our threshold.
So that threshold will keep your hash map sane. Otherwise, if you don't have that threshold, your hash map will explode and it will have so much data.
So,
yeah.
So Abhishek, are you also planning to store with apples the n value in the hash map?
In the hash. So right now, I have not. I think I don't need it.
Okay.
Because they will be stored in their ranked order.
Okay. In the
so the next question I had was, someone mentioned dropping the oldest item from the hash when it needs to be updated. I'm not sure why you said oldest rather than least frequent of those K that are listed.
Okay, if I said oldest, I was wrong. I meant to say least frequent. Yeah.
Okay, good. Thanks.
Yeah.
So, okay.
So wait, one
Go
question
ahead.
here. So because we are discussing, I think it's not my interview, and we are discussing it as a design problem. So I want to know, are there any better approaches that people can think of, or like or are you trying to understand it? Because yeah, this was my thought, and are there other approaches that could be better?
I'm just trying to understand. That's my intention here. Like, so whatever idea you're presenting, I'm just trying to understand, and I'm honoring your idea. That's it.
Yeah, no, Asim, yeah, I agree. I wanted to know, are there any better solutions?
See, that's why we will go to better solutions. So this is like a collaboration kind of thing, not an interview.
I'm wondering if there's a use in identifying which nodes are correspond to like a full word. So for example, app is, you know, a full word. Apple is a full word. So like, you know, if in those nodes you can actually say, okay, this is actually a final letter for some existing word in our dictionary.
Yeah, so
I think that could be useful because then the suggestions that come back are not going to include, let's say, plural or like kind of. It's just a potential improvement.
Okay.
Yeah, and my suggestion is primarily on the storage piece in the hash itself. Like Abhishek is storing a sentence, and I think your initial requirements are like 25 characters could be the one, or sentence could be much more longer here. If you will store whole sentences with everything, it's gonna explode. Maybe store them somewhere as one instance of a long string, and then store a pointer of that here instead of or a hash value of that, so that you can easily pick up. Yeah, then storing the whole.
Okay, so these terms would be hashes, right? We can store the hash. These terms can be hashes. They don't need to be a. So hash
The right
map.
side.
Yeah, this is key. So this is a hash of these terms.
Yeah, but the right side also, where you're storing, the whole sentence itself, the comma separated, those also.
Okay, those also we can probably, okay.
You can put in a list, and inside the hash value, put the reference to the node.
To that, okay. Yeah.
Because if the sentence is long enough, you will have significant.
Yeah.
Maybe the left one is probably not more interesting than the right one.
Yeah. Okay.
But Abhishek, do you think like this could explode the hash map?
Yeah, I mean, the size of hash map will be big, and that's why I was thinking of partitioning the hash map.
I'm not
So
sure
here,
I'm not sure if my previous point was understood. You can have words within words. So for example, all is a word, but alloy is also a word, but it's much rarer. So you want to be able to, right now, my impression is your setup is just looking at which terminal node has the highest frequency, but you need to include the possibility that there's some word that ends earlier that is very frequent, right? So that imagine all is 500 and alloy is 10 or whatever.
So what you're saying is that we need to store whether this is an ending word or not. So that can be tracked by the frequency. The characters, the node which have frequency, that means they are those complete sentences. So because AL does not has any frequency, that, or it will have so less frequency that it is not considered as a sentence for me. So now you said that all has 500 frequency and alloy has very less frequency. So I know that these two are the terms. So for A, when I'm creating the hash map, I will pick the top K most frequent. So all is the most frequent for me, and I will store all. And if alloy is not making up as the most frequent one for me, I will not store it.
Yeah, so right, because I mean, beforehand it just looked like you were looking at what's terminal on the try, but you could have non-terminal nodes that are actually correspond to the end of a word. So yeah, you want to account for that somehow.
Yeah. No, you will store frequency of everyone which completes the sentence. You will not store the frequency always at the terminal nodes. No, I will do.
Okay.
And actually, it could be driven by the user itself, or or all the users itself, because there's some things that are not in dictionary. Maybe some names and all that, right? So if somebody is typing a word with space, it means it's it's terminal word.
Yeah. Okay. Yeah.
Yeah. Should we move on a little bit? I mean, yeah, it's interesting, but let's go further and then we can come back, right? Because I think we have only 40 minutes left. So, this was the basic data structure I talked about, and then I think we have already discussed about hash and try. Why would we need hash? Why would we need tries, right? So now, how would the read path look like? So yeah, so for read part, we need to know on what particular node my hash exists, right? So because these hash, they can be partitioned based on the hash partitioning. So for that particular prefix, I will first need to know that where the values for that hash will exist. Once I have that node, I can just search for that key and it will return me the values, right? So this is the basic simple path, which I was saying that for read, you just need to go to the hash. For write path, uh, so for write path, you have to go to the tries, right? So first you need to find on what node your try is stored. And so basically we will discuss this, that we might also need to shard the tries. One try will obviously not fit in one machine. So first you need to find that on what node your this try will exist. Then you will update so let's say the word was apple, right? So you will update the frequency of apple to n+1, right? And then you will go to all the parents and see for its parent if this apple existed or not. If it existed, then you will increase its frequency. If it did not exist, then you will compare it with the words that exist for APPL and see whether any of the sentences frequency is lesser than the frequency of apple, because the frequency of apple has now increased. And then you will replace that sentence with apple now, right? So
Don't you just need to take the kth one?
what do you mean by
So
K?
let's say you have the top K suggestions for APPL. The kth one is going to have the lowest frequency of those 10, and if it's let's say you're doing top 10, you just need to compare that to the n+1.
Yeah, right. So we need to compare. Although we might need to do reordering and such, but yeah, if it's an increment of 1, then yeah, we can just compare it with the last one, because we can check if it is greater than the last one, then it can replace the last one, the kth one.
You're right that you would have to do reordering, like you said. Yeah.
Right. So, and then appropriately, if the hash map needs to be updated, we will update the hash map. So this is what my write will look like.
Well, when you're writing, right, I think that itself is a complicated problem. When you are updating, even if you're making it n+1, you have to probably, traverse your parents, all the children as well, or straight away to the nth node to figure out which one are the top priorities for the parent node and update out there.
Yeah. So for this update, you will go to its parents node. You don't need to go to children. For each parent, right? For APPL, you will see that whether this term apple existed in the hash map or not. If it existed, then it's good. You will just update its frequency. If it does not exist, let's say this was not exist, then it means that this has the probability of being the most frequent one. So you will compare it with the kth element here and see if it can replace it. And similarly, then you will do it for APP, you will do it for this. So you just need to go.
But you need, along with not just this one, your parent might have, some words. How do you keep track of your parent might not have this word, and the other siblings of the one that has just been updated, those might be giving more frequency or less frequency. How do you know that?
Yeah.
So I think what he's asking is, let's say you percolate up and you get back to the A, maybe all and some other words are in there.
Mm-hmm.
So I guess he's saying, how do you find out what those frequencies are? Are they stored at the level of A?
Yeah, so for A, whatever are the top K frequent, I have stored them in the hash map, right?
But are you storing the frequencies there too?
Yeah, we would need to store the frequency, yeah, because that's how we will compare
Yeah.
it.
So is that is that stored in the try, or is that stored in the hash? Because I assumed it was stored somehow in the try.
Yeah. You probably need to traverse the whole tree.
No, you don't have to traverse the whole tree.
I think it's better to store it somewhere, and because hash map already has information, we can store that number in the hash map. Because otherwise, then we will have to, yeah.
But then if you store in hash map, then with every write you are going to update the hash map as well, correct?
Yeah. The frequency. Mm-hmm.
So that's why if we can store the reference, and in that reference, if you have the frequency, and hopefully, I don't know, maybe that should help.
Weren't we worried that that the reference and weren't we worried about partitioning in this in the case of storing a reference?
I think top K we shouldn't partition, right? That's what my understanding is.
No, top K we are not partitioning, but my problem was that like if we have references to this try in this hash map, then there is the problem that when you are modifying this try during the writes, then how will you read the data? That data might be inconsistent for that time. So now
I'm thinking in my head something, but I will drag the discussion in some other direction, which I don't want to do. I never thought of this as an online thing. I always thought this suggestion to be an offline thing because it's not that critical enough to be updated online.
Yeah, that was another point which I will go in the future. This was my initial point, right? That real time or not. If we want to update the things real time, then we would have to update the try immediately. But the other approach which you are saying is that offline processing, which I will mention later, where you are just storing your writes in a database or somewhere, right? And then you are doing the offline batch processing where you are taking those batch of writes and then applying to the try and doing the calculation and updating the hash map. So
Right. So at any one point of time, I'll have one try active while I'm taking a snapshot of it and doing background processing, offline processing, and re-updating the try. And then once that processing is done, I'll just switch, with the new try.
Yeah, that is another approach as well. Yeah. Okay, so yeah, I think people have moved ahead a lot. These things I have mentioned. Okay, so now going to scaling reads, right? So let's say now we have read hotspots for some particular keys. There are a lot of people searching for those keys. So if we want to scale reads, we can replicate those nodes. I think it should be hash nodes. Sorry. So those particular nodes which we see they have high read, we can just replicate them, right? But now coming that scaling writes. So what if a particular try, it has lot of different type of sentences which cannot fit on a single machine. So now we have to partition that on a different machine. So before we were doing replication, now we would have to do the partition, right? So how will the partitioning look like? So this is what I was thinking of, something like this. So let's say your try was initially like this, A, B, Z, right? And so your partitioning was that all the keys with the A are stored in machine M1, with the B, they are stored in M3, and with the Z, they are stored in M5. Now your try for A under A has increased so much that it cannot fit on a single machine M1. So what you will do is that you will again split it, that the try up till AP is on machine M1, the try up till AR is on M2. So now when a key term comes for the write, so you will go here A, so then you will remove this information. So you will go here A, and you will see that I have not still found a machine. So I will go to P. Oh, I have found the machine M1. So now I will go to M1 machine to write the data for that try.
You probably need multiple M1s.
So
and maybe if a machine, if M1 goes down, how will M1 come up again?
No. So replication.
You need a persistent database also.
Let's not mix replication and partitioning. Replication, you have to always replicate the data, right? There is no denying that you will keep everything on the node. Whenever you are making distributed systems, I think you should never think about that there is only one machine M1 storing this data. You anyways you have to replicate. I'm talking about partitioning, that the data for A cannot fit on a single machine and you have to partition that data, right?
Okay.
So how will you partition that data?
And along with the, I think that's a good point that you brought up here. Along with the partitioning also, you need a persistent storage also, right?
Yeah, we need, yeah, that's a good point. So we will need a persistent storage also. So whenever that sentence come that you have to write, you will also write it in a DB, maybe a append only log, and then you will update the try. So yeah, so I think, yeah, so when we will go to this final design, so here you will see that when you're updating the tries, you are also updating it in a DB and that in-memory try so that you don't lose your information. So yeah, let me completely finish my slides. So this was another approach which someone was suggesting, right? That real-time versus offline updates. So if we are doing this, the system which I was talking about was the real-time updates, right? Where we are updating try on every write, right? And this we can consider kind of the stream processing system, that for every write, every write stream, you are updating your try. If you are okay with few hours of delay, right? If you don't need a real system, what we can do is we can quickly store the writes in a DB without updating the try. And later on, we can take those batch of writes. Oh my goodness, I have written. So you can take those batch of writes and then you can apply it to the try, right? So this will be kind of a batch processing. So, and then this offline system can also have this other things which, like Vivek mentioned last time, that they can have time decay thing, that they are also updating that weightage of those key terms, and they are regularly decreasing the weightage. So when they decrease the weightage of the terms, they need to update the try, they need to update the hash map. So all that can be done offline, right? That every 1 hour, I will decrease the weightage. And with, as I've mentioned, with offline updates, we also avoid the problem of concurrent writes, because now we are controlling the writes. We are just creating that final try, and then we are updating that try. So the problems which we were facing with those concurrent writes, we will not have those problems here. Okay, so let's now quickly look at this high level design of the system, and then let's discuss more. Okay, so basically, so let's say when a user makes a read request, right? So the read request comes, it goes to this application server, right? And so the application server will need to look that for this particular prefix, which machine will have my hash keyed values, right? This is partitioned with the hashes. So these nodes are replicated, as Hitesh was mentioning, that what if they fail, right? So these are replicated among themselves, and the data is partitioned like this with different colors. So from this config management service, you find out that for this particular hash key, what node should I go to? This will return you that node you go and fetch the values from that node and return it to the user, right? So this is your read path. Your write path, either this write path could be that online system or this offline processing system. So first let's discuss this online system. In online system, when you send a write, it will be sent to the application server, and this application server will look at this config service that what try should I go to. So and here now this will also be a try. So I'm basically talking about this part, that which machine it should go to, right? So this information it will get from some config management service, which will tell it that you need to go to this particular try, right? Then it will do a write only log in the database so that information is not lost. And then it will also update the try. When the try is updated, with the update of the try, you will also need to update the hash map. So it will update the hash map. And yeah, so that's the thing it needs to do. The offline processing system, if we are taking an offline processing system, what it will do is it will read the data from this database, right? And from this database, it will take those batch of things and it will apply those to the try, right? So first it will go here, and then second it will apply those to try. And once you have that updated try, you will update your hash map. So the third step is you will update your hash map.
Would you still expect like a step 4 that updates the try at the top where it says config management service?
So are you talking about read, write, or
No,
offline?
I'm talking about the offline. So you have 1 and 2,
Yeah,
but then you have 3. Wouldn't you expect a 4 as well?
Yeah, to update the config service. So yeah, the config service will be updated. So the config service will be updated whenever there is a rebalancing, right? When you are storing the data in different. I'm sorry, someone's mic is on. Yeah. Okay, so I'm saying the config management service will be updated when you rebalance, right? Only when you rebalance, then it will be updated. Okay, but it also needs to go to the config management service to know which try. No, but the offline processing system will just process all the DBs, right? So it does not need to go to that particular database. So I was thinking that's why it does not need to go to the config management service first. It will periodically, it will iterate through all the DBs. It will update the tries and it will update the hash key. And
So
it will
I see that red arrow with the 3 next to it as analogous to the green arrow with the 7 next to it.
This 7.
I think offline processing jobs will also need to talk to config management service to gather the snapshots at each and every partition, right? And take that, I mean, in the offline processing case, and take those snapshots, work on it. But then while writing it, if there are partitions already taken, but partitions already happened, our data is rebalanced, that's one critical thinking and corner case that let's not talk about it as of now. But let's say nothing has happened during the offline processing and the partition is still intact, the same number of partitions we have, we can write it back.
Okay.
How would you, so if you had the diagram, like where would you actually draw the arrow from?
So I'll draw an arrow from offline processing job to config management service.
Yeah, okay.
For me to know what partitions are there currently. Right?
Oh yeah.
Then I have to go through all those partitions to gather the snapshots and take those snapshots and do the processing. And assuming, like there is one asterisk I'm putting there is, partition is still the same. Like that has not changed. So that I know I have to update the same partition. But if the data has changed, then I have to redo it. That's what it means. I have to redo it because now my data is moved to some other place. Depending upon what type of partition we are doing, if we are doing range-based partition or if we are doing size-based partition.
Okay.
Yeah,
Yeah.
one question I have, like since we are using try and offline, so primarily on offline processing system itself, we are using try also, and we are using an offline processing to update the try and then take the try to hash map, right, Abhishek?
Yeah. Yeah.
So can't we just the offline processing itself read every content from the database and generate that hash map itself?
Yeah, I mean, that is what I was thinking when we started this session. I mean, online, I mean, I never thought about online first of all. But that's a good, interesting idea to have it online. Like, Right-Head Suggestion is one such application, but there will be another application where you have to do things online. I mean, Typeahead Suggestion is one such application, but there'll be other applications where you have to do things online.
Yeah, and I mean, the article which I was reading, yeah, there they wanted to do it real time, but again, yeah, but I don't know how these actual systems are they real time or not. So
I think the very nice point that you made initially is like, you know, the eventual consistency is something, right? You know, not a, so no doubt these two are totally different things. I believe the architecture will be different for an online versus offline system.
Offline, yeah.
Yeah, I mean, in offline, like probably try is a very good thing where you want to read and write fast and then traverse and all that. But if you're doing in a batch processing way or in an offline way, you probably don't need a try. You can keep things in a database or somewhere, and you can do a big data processing, analyze everything, generate a fresh hash list, and update it on all the machines which are going to be directly read.
Try comes naturally because just of the prefix match, like longest string match, like in the networking world where I mean, at least I'm not doing networking, but in the networking where we match the longest, like the next hop and the next route that I want to see, and the next, like, so this goes along the same way, like what is the next string which is going to come from here, right? When I'm APPL, then when I'm at L, what is the top K from L? Then what is the top K from Apple? It might be space and some another sentence that might start.
So yeah, I think even in this batch processing also, you would need to create try internally to calculate that what are the top K frequent, because otherwise, I mean, it will be difficult because what you will do is you will read your database, you will read that first row, you will create a try second row, and you will keep on creating the try. And then based on that try, you will update your hash.
Yeah, your point is valid. Whether we do a try or something else, right? The thing I'm making here is, why do we need to maintain a try at all? You know, as a part of batch processing, you directly read from the database. You generate as a part of offline processing, you generate a try, do all those or anything else. You come up with what should be the highest for every word, every proper word or so, or every something that is treated as a word. And then you come up with the hash, and then whatever in config management you have defined your partitions, you update the hash on each and every machine one by one, and then you deploy yours.
But the point is, so in your batch processing, are you going to process all the data every time, or are you going to process only the new data?
We can choose it, the incremental way and non-incremental way, both way. I mean, it all depends on how you write your batch processing.
So in non-incremental way, every like few hours, you will be processing like your thousands of days of data in the DB. Is that what?
Yeah, I'm talking about big data processing here. You know, where you have all the data that is available there. Using any big data solution, you can process all of them in a much faster way, not as a transaction, but you process all the data and you come up with what should be the hash, and then that hash can be replaced on the
your data is increasing, so wouldn't like eventually your bad jobs will take a lot of time?
data is not increasing, only the count is increasing. Actually, data is not increasing that significantly because it's the frequency that you said that increased faster, right?
And even in the batch processing, we don't keep on chasing the tail. We take a cut at certain time. We say, okay, let's process the data, whatever happened till last minute, and then just stop it. We don't keep on chasing the tail. I mean, that's the logic of the batch processing, right?
Yeah.
Yeah, I mean, I was thinking that you process only that data which you have not processed. So let's say your batch job is running every 5 hours. So now that last 5 hours of data you have not processed, so that 5 hours of rows you pick, and then you update your tries with those 5 hours of rows, and then based on that you update your hash maps.
So incremental is a good, undoubted. So there are two things that are coming up here. We are getting the new sentences, the new words, and we are also getting to see the increment. So this is the new data that is coming, right? Now, as far as processing these transactions, these are transactions that are coming in, right? The new entries and all that, right? You could probably directly, put them into the database because those are new entry, or you could also increment, as a part of your app server, you increment those counters that, that this has been read that many times and new sentences came in. So what I was saying, in an offline or in a big data processing world, you can read all those sentences or words that are there in the DB. And let's say in the full processing mode, you can generate a hash out of it. I mean, the hash data that eventually is going to be consumed by it. So you read everything from database to one processing, you generate the hash, and then whatever partitions you have for your hash storage, you put them out there. As a kind of deployment, or as a kind of you can put them there, and then maybe later on in a hot and cold path also that can be think through on those machines.
Yeah. Okay.
But the thing that I'm saying, it will not fly when you want to have a very fast processing here, because the big data solution or something that's probably only where there's a latency, definitely and it's not something that can be done in a transactional world or so, where you want to make it much faster. It has to be a significant delay if you want to go through that route.
Okay. So I think we are done here. Is there any other?
Yeah, I would like to, if you can clarify, can you go back to the slide and have a try?
This try or
yeah. So like, if let's say user type Apple Store, okay? So how would you index that? Because the store have to be depend on the previous word is Apple, right?
Yeah. So we are so how we are storing in try, according to my approaches, you will be storing Apple, and then space will be that another character, and then store. So that Apple, so you will have that one big branch which is Apple space store. So these are not stored as separate words. So the end-to-end flow will be that for the right path, that you will see that A, then P, you will match AP. So you will know that the try for AP, starting with AP, lives in machine M1. So now you will go to machine M1, and now your machine M1 will have the entire try which starts from AP. So there you will see if Apple Store exists or not. If it exists, then you will update the frequency. If it does not exist, then you will add this new try branch to your try.
So when you, let's say you're done with the Apple and then you see space, and now the next word is store, is that you go back to the root of the try to find the store, or you build another try?
No, it will. So I'm saying it will be stored like this. A P P L E space store.
Oh, that's going to be a lot, right?
Yeah.
Because it can be go as deep as the length of the sentence.
Yeah. So that's why. So let's say your branches for this AP start to increase. So that's why you will shard and partition your data so that your your keys starting with these kind of terms are separated. So even if the size increases, they can still be stored. But I don't know how would creating separate I don't know. Is there any other approach which you have to suggest?
No, I just want to see, how you solve it. I want to clarify. But this would potentially, we could build multiple try, because Apple's one try and then stores another try under that.
It's not. I mean, I don't know what do you mean by another try, but yeah,
So
yeah.
let's say you have Apple, right? And then after Apple, you have Apple app, right? It begin with another A.
So you are
right?
saying Apple and then app, okay?
Yeah.
So it will go like this.
I think it, yeah. I don't know. It looked like it's a nest kind of the nested try to me.
Okay. Yeah, I mean, try is that kind. It's kind of that recursive data structure, right? That at every node you will have that another try kind of node. So it itself is recursive
Okay.
data structure. But yeah, my point was that if like there are a lot of terms that start with A and the Apple and they cannot fit, then you can shard at this point that like all the nodes which start with Apple A will be on one machine, Apple S will be on another machine. So now when this term will come, first you will look into this your mapping service. So you will see APPLE. Okay, it's on this machine. So you will go to that machine and then you will find that entire term. Okay, I think Naga, is there any other question or otherwise I think I can stop sharing my screen and we can wrap up early.
What was on slide 15?
Oh,
okay. That's fine.
Yeah.
Never mind.
Do we want to discuss concurrent writes? I mean, I don't know if we have enough time, but.
Yeah, we don't have enough time. I think this was a good session, at least like understanding two different thoughts. And thanks for putting these slides together, Abhishek.
Yeah, no problem.
So should I stop recording, Naga?
Yes.